Namaskara. Dear students, in today's lecture we will discuss about post-harvest losses of fruits, vegetables and preservation. Introduction. There is a renewed interest in vegetables in light of the recent findings on their health promoting properties. Vegetables are highly perishable agricultural commodities due to high moisture content and higher metabolic activities. Botanically, a fruit is the ripened ovary or fruit is an ovary that has ripened after fertilization. An important cause for vegetable spoilage is microorganisms. The source of microbial includes fecal matters, transport rot, Erwinia pseudomonas, water and soil pathogens, yeast and molds present on vegetable surface. There are reports stating that physical contamination, insect and dust processing conditions wherein storage temperature acts like a booster. Gram-negative bacterial flora causes major spoilage of vegetables. The post-harvest handling produces such as hygiene and safety conditions during transportation, quality of microbes and food with special reference to vegetables. The post-harvest losses recorded during previous decades are alarming. Spoilage of fruits and vegetables mainly occur due to microbial attack, autooxidation and insect pest attack. As a result, about 25 to 30% of production is lost after harvest due to improper handling, storage and microbial contamination. As processing technology is an young science in India, existing knowledge about the way in which minimally processing along with edible coating like carnauba and nisin can improve the shelf life of vegetables during storage at room temperature as well as at low temperature. These spoilage organisms thrive and multiply faster at ambient temperatures and high humidity. Many of these spoilage organisms multiply even at low temperature during refrigeration. Refrigeration of vegetables for a long period results in spoilage due to the growth of psychotrophic bacteria. They are capable of surviving and multiplying in refrigeration temperature. This episode deals with following: production and processing in India, post-harvest losses in Asia Pacific region, common cause and type of post-harvest losses, microbial and physical loss, preservation and prevent spoilage. Table 1, fruit and vegetables production in India, you can see in this table. Common cause of post-harvest losses can be divided into two major groups: physiological disorder, post-harvest factor. Physiological disorder causes pre and post-harvesting factors. Pre-harvesting, ammonization, zebra skin, fruit splitting, sunburn, wind scar and freezing. Post-harvest factors, temperature, humidity, exchange of gases and mechanical stress. Aging factors, puffiness, pitting, chilling, injury and granulation and freezing injury. Table 2, estimated level of post-harvest losses in Asia Pacific region can be seen in the table. Microbial losses due to disease, contamination of vegetables and pathogenic bacteria. Many types of post-harvest disorders and infectious diseases affect fresh fruits and vegetables. Using polluted muddy water or stream water for irrigation can also contaminate produces in the field. Soil and decay plant materials in the field can contain post-harvest pathogen in great abundance. Vegetables are exposed to various types of contaminants. They generally contain heterogeneous microflora. Total microbial population depend on the field organisms and other bacterial encountered. Hence, galaxy of pathogens that form surface microflora of vegetables are Salmonella, Aeromonas hydrophila, Listeria monocytogenes. Association of vegetables with the outbreaks of human listeriosis is often reported L monocytogenes have been isolated from cabbage, cucumber, radish, tomatoes, salad vegetables, bean sprouts, etc. Post-harvest losses. Number 1, disease, fungi and bacteria. Number 2, injuries, mechanical force, heat or freezing or chilling and due to chemicals. Non-disease disorders, overpacking or underpacking of field or marketing containers, carelessness handling such as dropping or throwing or walking on produce and packing containers during the process of grading, transport or marketing. Post-harvest losses may occur at different level during the market chain. Losses of harvest, injuries, pressure damage. Losses at the packaging house, chemicals, brushes and wax damage. Losses during storage, chilling injuries, decay, peel disorders. Losses during transport, bruising, deformation, decay. Losses at retail, decay, softening, wetting. Losses at the consumers, decay, softening, wetting. Table 3, composition of fresh fruits and vegetables, you can see in this table. Like vegetables, fruits are nutrients rich substrates, but the pH of fruit does not favor bacterial growth. As a result, yeast and molds are more important than bacteria in the spoilage of fruits. Vegetables are a good substrate for yeast, molds or bacteria. Microflora of vegetables is primarily composed of gram-positive bacteria like lactic acid bacteria. Example, Leuconostoc, Lactobacilli, Streptococci, Corinoforms and Streptococci. The latter coming from the hands of employees during processing. Staphylococci are usually unable to proliferate at cross-contamination can introduce them into the other foods where growth conditions are more favorable. Penicillium expansum and Bacteroides cinerae are well-known post-harvest pathogens. They produce blue and grey rots, respectively soft rot. One of the most common type of bacterial spoilage caused by Yersinia carotivora or sometimes by Pseudomonas species which grow at 4 degrees centigrade. Because bacteria grow more rapidly, they usually outcompete fungi for readily available substrate in vegetables. As a result, bacteria are of greater consequence in the spoilage of vegetables with instanting properties that supports bacterial growth, favorable pH. Mold spoilage in vegetables where bacterial growth is not favorable. Example, low pH. Molds are the principal spoilage agents. Most molds must invade plant tissue through the surface wound such as bruise or crack. Spores are frequently deposited at the sites by insect like Drosophila melanogaster, the common fruit fly. Other molds like Bacteroides cinerae which causes grey mold rot on the variety of vegetables are able to penetrate fruits or vegetable skin on their own. Source of contamination, surface contamination, soil, water, air, human pathogens from manure. Harvesting, hand packing, machines, high damages if crop is ripe, harvest before ripe. Geotrichum candidum mold on harvest. Packaging containers reused. Processing plant, markets handling cross contamination. Fruit spoilage by following organisms. Several genera of yeast can be found on fruit because these organisms grow faster than molds. Yeast often initiate fruit spoilage, then mold spoilage by degrading complex polysaccharides in cell walls. Specific spoilage organisms Blue mold rot, Penicillium, it causes fruit. Downy mellow, Phytophthora, large masses of mycelium and grapes. Black rot, Aspergillus and onions. Sour rot, Geotracheum candidum and citrus fruits. Bacterial soft rot caused by Erwinia carotivora is a plant pathogen belongs to the family Enterobacteriaceae. Pseudomonas species, Clostridium and Bacillus species have also been associated with these rots. It results water-soaked appearance, a soft, meshy consistency and often a bad odor. Grey mold rot caused by species of Bacteroides. Example, B. cinerae, which is favored by high humidity and warm temperature. Rhizopus soft rot caused by species Rhizopus. Example, R. stolonifer, a rot result that often is soft and meshy. The cotton grows on the mold with small black dots of sporangia often covered masses of the foods. Alternaria rot caused by Alternaria species and other species. Areas become greenish brown early in the growth of the mold and later turn the brown or black spots. Blue mold rots caused by species of Penicillium digitatum and others species. The bluish green color that gives the rot its name results from the mass of spores on the mold. Downy mellow caused by species of Phytophthora brumea and other genera. The mold grow in white woolly masses. Watery soft rot caused by Scleraciana. Scleratum is found mostly on vegetables. Stem end rots caused by species of molds of several genera. Example, Diplodia, Alternaria, Phimopsis, Fusarium and others involved the stem end fruits. Black mold rot caused by Aspergillus niger. The rot gets its name from the dark brown or black masses of the spore of the mold turned smooth. Black rot often caused by species of Alternaria species. Pink mold rot caused by pink sporated Trichoderma roseum. Fusarium rots, a variety of types of rots caused by species of Fusarium. Green mold rot caused by usually species Cladosporium, but sometimes by other green spored molds, example Trichoderma. Brown mold rot caused by Scleraciana. Sliminess caused by saprophytic bacteria, the wet heating vegetables. Fungal spoilage of vegetables often results in water-soaked meshy area, while fungus rots of fleshy fruit such as apple and peaches frequently show brown or cream colored area in which mold mycelium are growing in the tissue below the skin. Aerial hyphae or spores may appear later. Some types of fungal spoilage appear as a dry rots, where the infection area is dry and hard and often discolored. Rots of juicy fruits may result in leakage. The composition of the fruits and vegetable influences likely type of spoilage. Thus, bacterial soft rot is widespread for most parts among the vegetables which are not very acidic, because most fruits and vegetables are somewhat acid or fairly dry at surface. Thus, the character of the spoilage will depend the product attack and the attacking organism. Fungal spoilage during storage can be seen in these figures. Physical cause of vegetable losses. Vegetables after picking and before processing are alive. Physical and chemical changes takes place after harvest and continue during storage periods. Major physiological changes ensuring post-harvest period are loss of moisture. Loss of moisture leads to rapid shriveling and loss of crispiness. Plant tissue become eventually inedible. It leads to loss of soluble carbohydrate and reduction in weight. Moisture loss from surface initiates immediately after harvest and continue during storage or transportation period. Loss of stored energy. Vegetables are living tissues. Respiration that occur during post-harvest period require energy. The stored carbohydrates are degraded for the purpose of energy supply. Loss of food constituents. Moisture loss during storage is the major factor responsible for nutrient loss. The most labile nutrients that are lost are vitamins. Fiber developments. In the vegetables such as beans, nolkol and carrots, pectin degradation takes place as a result of moisture loss. The tissue become hard and fiber development takes place. Root and shoot developments. Certain vegetables like beans, potatoes, root vegetables develop such parts during storage. Loss of nutritional important pigments. Chlorophyll, carotenoids, lycopenes and xanthophylls are degraded during storage. The extent of loss are proportional to period of storage atmosphere. Overall quality. Owing to these described above, the stored vegetables have poor overall quality. Chemical and enzyme spoilage occurs, especially vegetables and fruit are damaged by filling or breaking. Such damages can release enzymes that triggers chemical reactions. Tomatoes become soft, for example, apple and other type of fruits turn brown. The fruit can also become rancid. As soon as the peel of fruit is damaged by falling, crushing, cutting, peeling or cooking, the chances of spoilage increases considerably. Preservation and prevention. Enzymes can be deactivated by heating the fruit or vegetable. The same effect can be achieved by making of fruit or vegetable sour or by drying them. The peel of the fruit or vegetables provide natural protection against microorganisms to retain the desired quality of the products longer than if it was simply stored after harvesting. It must be preserved. The preserved food, it must first be treated with the goal of stopping physiological changes and enzyme changes and preventing the growth of microorganisms. Respiration is a continuous process in a plant and cannot be stopped without damage to the growing plant or harvesting produces. It uses stored starch or sugar and stops when reserve of these are exhausted, leading to the aging. Fresh produces continue to lose water after harvest. Water loss causes shrinkage and loss of weight. These perishable commodities need very careful handling at every stage. It is important to minimize mechanical damage by rough handling and ruishing during the different steps of backhouses operation. Marketing of fruits and vegetables is the major bottleneck. 30 to 40% will get perished because of poor marketing infrastructure. Recommended practices for preservation and fruit and vegetables. Wash your hands thoroughly with hot water and soap before beginning to prepare food. Make sure that kitchen utensils and appliances are well cleaned and disinfection. Always store food in a clean place. Use herbs and spice as little as possible because they are an important source of contamination. Use clean and pure salt only if the salt is not pure. Eat it on a dry metal sheet above the fire. Allow only clean drinking water to come in contact with fruits and vegetables. Conclusion. All over India, people are suffering from nutritional losses and acceptability determination as well due to the drastic method of processing and preservation. India is the second largest country to produce horticulture food according to Food and Agriculture Organization, that is FAO statistics. Many factors contribute to post-harvest losses in fresh fruits and vegetables. Post-harvest losses can be defined as losses of horticultural commodities in quality and quantity after harvesting till consumption. Fruits and vegetables are living parts of plants and contain 65 to 95% of water. The source of microbes includes fecal matters during transport, insect, dust and processing conditions, where in storage temperature get like a booster. Gram-negative bacterial flora causes major spoilage vegetables. They thrive and multiply faster at ambient temperature as high humidity. Several essential nutrients are required for human health. Fruits and vegetables are the rich source of vitamins, minerals, antioxidants and fiber. The deficiency of vitamins may lead to many diseases such as scurvy, beriberi, night blindness, etc. Food spoilage can also be caused by the action of enzyme which is chemical in nature present in the food. The speed up chemical changes that result in loss of flavor, color and texture. As enzymes are mainly composed of protein, they are sensitive to heat but loss active in low temperature. Enzyme against cause browning in certain foods the moment they are exposed to air. When you cut or bruise foods such as apple or yam, the exposed surface will discolor and turn brownish due to the activity of enzymes. Some enzymes remain inactive once activated. Such enzymes speed up the process of decay by breaking down the tissues and spoil the food in various ways such as oxidation, browning and ripen. Oxidation: when oxidation occurs, that is when food comes in contact with oxygen, the enzyme causes the destruction of certain nutrients, example vitamin C, thiamine and carotene. Effective elimination of post-harvest losses has been required good knowledge and idea exchange among the farmers, scientists. Maintenance of the physical appearance, flavor, market value is must for consumers. Several preservation methods like cold storage, modified and edible coating has been used for keeping the fruits and vegetables for longer period. Eating a diet rich in fruits and vegetables as part of an overall healthy diet may reduce the risk for stroke, cardiovascular disease, type 2 diabetes and many protect against certain cancers. The potassium in fruit and vegetables may play a key role in reducing the risk of developing kidney stone and may help in decrease bone loss. Eating fruits and vegetables that are low in calories and high in fiber and may help in individuals reduce their overall caloric intake to assist the weight loss and support the maintenance of the healthy weight. Fruits such as mango, grape, banana, lychee, sapota, pomegranate and vegetables like onion, potato and green vegetables have good export market potential. Growers will not have proper infrastructure facilities for handling or storage of produces in growing area. Minimize of post-harvest losses from harvest to consumer table depend upon the several factors, biological, environmental aspects and use of appropriate post-harvest technology. It will reduce losses due to spoilage, add value to the fresh fruits and vegetables.